Hello, my name is Burhan and I am a PhD student in Green Lab at Georgia Tech, and today I'm going to be presenting our paper, Uncertainty Characterization in Active Sensor Systems with DNN-Based Feedback Control. So let's get started. In this paper, we characterize and utilize uncertainty information in a closed-loop ROI-based imaging system with a deep neural network defining the ROIs. Now, this is an important problem to solve because in a real-world scenario, it will be very hard to measure whether the DNN is behaving correctly, and that will affect your feedback operation. So the way that we solve this is we measure the uncertainty of the detections that are coming out from the DNN. That in itself is a very hard problem to solve, but there exist some approximate techniques that revolve around the idea of sampling. What we do is we sample the deep neural network multiple times and construct an output predictive distribution. These multiple samples can be taken from the network using a technique called dropout. What dropout does is it randomly turns on and off neurons within the network, giving us different outputs each time. Given enough samples, we can construct an approximate distribution of the output variables, such as the label of the class and the bounding box. So how do we use this? So we apply the uncertainty characterization techniques in a feedback system for the tasks of object detection, object tracking on the CAMEL dataset. The CAMEL dataset has RGB IR paired sequences with annotations for pedestrians, cars, and other miscellaneous objects. If you look at two different sequences, sequence 3 and 30, 3 is a well-lit sequence, so there is no difference in the uncertainty for the detections for RGB and IR. But if we look at a poorly lit sequence, we see that the RGB has a much higher uncertainty when objects are transitioning from well-lit areas to poorly lit areas of the frame and vice versa. So we are better off using IR in that sense. Keeping that in mind, we propose a hybrid control scheme that not only uses the score of the detection, but also the uncertainty of the detection to control which ROIs will be fed back to the sensor. With our hybrid control scheme, we observe that we are able to improve the success metrics all across the board. For example, we improve average precision for object detection, tracking accuracy for object tracking, and also the number of true positives, and false negatives. If you have any questions, I am available to answer them, and please, for more details, refer to my paper. Thank you.